Good morning, students. So in this video we can discuss about how to construct Turing machine for some simple language. So here the question is construct a Turing machine so which recognize the language L equals to WCW, where W is belongs to any string. It can be generated by the A comma B as the alphabet. So now we will go for constructing the Turing machine for the language L is WCW. So here W is any string can be derived from the alphabet as A comma B. So that means which is the combination of ABs. So which may be AB, either A or ABA or BBA, either BAB, AA, BBA, in this manner. So W is the any string can be derived from the alphabet A comma B. So then the language contains WCW. So that means, for example, let W equals to AB. So then the language contains whatever the string. So in the place of WAB, after that C, again AB. So that means before C, whatever the string, same string can be occur after C. So that means, so which was having the same string occurs two times. So first time and first part and second part can be separated by the C. So this is the given language. So to generate Turing machine for this language, whenever we read first symbol from the first part of the string, first symbol from first part of the string, then we can move to right side. We can move to right side, and then whenever we find same input symbol after second part, so same input symbol in second part of the string, first symbol in second part, first symbol, then that particular symbol can be marked as some external symbol, which may be star or which may be capital A or anything. So it can be marked as some external symbol and then move back. So that means left side. So now we can move up to previously read input symbol and then move right for reading the next input symbol. So now we can read second input symbol and then move to right up to reading the C as the input symbol. After C, we can check is there any unmarked symbol. So that unmarked symbol and previously read input symbol both can be matched. So then that unmarked symbol can be converted as some marked symbol, external marked symbol, and then go back to the input tape. So that means move to left. So now we go back up to either previously read input symbol, which may be either A or B, and then move right and consider third input symbol from the input, third input symbol from the string, and then copy it into the memory and then move right until C. So after C, it will check is there any unmarked symbol or not. So in case is there any marked symbol, simply skip. So that means move right until we are getting the unmarked symbol. So in case is there any unmarked symbol, then we can convert that unmarked symbol. First of all we check that unmarked symbol and just now we copied into the memory. So whatever the input symbol, current input symbol, both are matched. Then this unmarked symbol can be converted as some external marker and then move back. So we can repeat the same process. Finally we are getting all symbols in second part of the string can be marked. So then we can say that particular language is accepted by the Turing machine. In case is there any symbol is not marked, then we can say that that particular string is not accepted by the Turing machine. So this is the procedure to develop the Turing machine for the given language. So by simply when read first part of the string in first symbol, same that particular symbol can be copied into memory and then move right until we are getting the same symbol after C. So here C is the separator between first part of the string and second part of the string. So after C, whatever the symbol, that symbol is matched with copied input symbol, then both are same. So then we can mark that particular symbol as an external symbol, which may be star or anything, and then move back. Again read second symbol and then move to right until getting after C, same symbol can be not marked, then we can mark that particular symbol and then go back. So that means move left. So in this manner we can moving left to right and right to left, and finally all symbols can be marked as some external symbols in second part of the string. Then we can say that the particular Turing machine is accepted by the, so that particular language is accepted by the Turing machine. So now we consider some example. There is some string from the given language. So let W is equals to ABA. Let we assume W equals to ABA. Then the language is W, C, and then W. So here just now we assume W is ABA. So that's why WC, W is ABA, C, ABA. So now we read first input symbol and then mark as star some external symbol and then move right until we reach the C. So that's why here first input symbol is A, copied into memory and then mark as star. So this A was marked as some external symbol star. So there was no restriction, it can be marked as the star. We can mark as any external symbol like capital A or capital B or capital X or some X symbol. So and then move right. So why we are moving right? So we check whatever the first symbol of the first half of the string, that is A, same symbol can be occur after C. So then we can say that particular language is valid one. At the same way, whatever the second symbol, that symbol can same symbol can occur after C as the second symbol, and third symbol, the same symbol can be occur after C as the third symbol. Then we can say that particular language or that particular string is accepted by the Turing machine. So that's why we read the first symbol and mark as star and move right. So from here to right side we will move right side until C. So that's why here next input symbol is B. So it was not matched with C. So that's why move right. And next symbol is A. So it was also not a C. So that's why move right. So next symbol is C. So now we should move to right and check next symbol is either A or not. Why? Because previously marked input symbol is, so previously we performing the marking in the place of input symbol A. So that's why after C same symbol can be occurred or not. So in case that symbol is same, then we will go to, so then we will mark this symbol is also as star. This symbol can also marked as star and then go back to read second symbol to check second symbol. So that's why move left up to previously marked symbol as star. So that's why here this A can be marked as star. So this A can be marked as star and then move left. So from here to, so this A can be marked as star and then move left means C. C we should move to the C. So next, so whatever the symbol, current input symbol C. So that's why again we should move to the left. So next input symbol is A. So again we should move to the left. So next input symbol is B. We should move to the left until we are getting the some marker symbol. So when we are getting marker symbol as the input, then move right to check second input symbol. Same as the after C second input symbol. Both are tallied or not. For that purpose, so we should move right side. So that's why now we move the right and consider what is the current input symbol B. So this is the second input symbol as B. So now we check same second input symbol after C can occur or not. For that purpose we should move right side. So that's why we should convert this particular B as star and then move right to mark after C second symbol as star if both are tallied. Otherwise that particular string is not accepted by the Turing machine. So that's why this B can be marked as star and then move right. So next input symbol is A. So it was not useful. That's why move right. Next input symbol is C. It's not useful. That's why move right. Next input symbol is star. It was also not useful. Next input symbol is B. So this B was occurred as a second input symbol after C. So and previously we mark B as star. So that is second input symbol from the first half of the string. Here second input symbol from the second half of the string, both are tallied. So both are same. So that's why now we convert this B as star and then move left to check third input symbol. So that's why we convert second B as a star and then move left until star. So up to here. So actually up to here. So up to here and then move right. So now the input symbol is A. So now the input symbol is A. So that's why. So now we can mark that particular input symbol A as star. This particular input symbol A as star and then move right to check after C. Third input symbol is same as recently marked symbol or not. Recently marked symbol input is A. So now we check after C third input symbol is A or not. So for that purpose we should move to right side. So that's why from here to mark as star and then move right. So that is C. Next current input symbol is C. Again move right, that is star. Again move to right, that is star. Again move to right. So now the input symbol is A. So recently marked input symbol is A. So recently we mark as star. So what are the input? A. So both are matched. So that's why now this A is also marked as star and then move left to up to star after C star. So that's why we should move from this can be converted as star and then move left here. So it was already marked symbol. That's why move left. Again move left C. So again move left. So here in between immediately before symbol of the C is star. That means there was no input symbols to performing the mapping. So that's why that particular string is accepted by the given Turing machine. So that's why it will go for halt. Here halt means nothing but accepted. That particular string is accepted. That's why we stop the process. So this is the process of performing the mapping. So by Turing machine. So now we observe how to construct Turing machine diagram representation for this particular mapping. So here what we should do till now, we read some input from the initial state or some state and convert as star and then move right up to C. After C we read same input symbol, then convert as star and then move left. We are moving left up to, we read star as the input. After C we read star as the input. So when we read star as the input, then move right. Again we check what are the input symbol. That symbol can be marked as star and then move right. So this is the process. So that's why. So now we construct Turing machine. So this is the initial state. So Q0 is the initial state. From initial state, our considered input string is A. So when read input is A, then convert as star. So that particular input is convert as star and the direction is right side. We should move to the right side. Next, so in this process, whenever we are marking some input symbol as star and then move right side, in this process we can read any number of A's, any number of B's, then we should not perform any operation. Simply move to the next input symbol or simply move to the right side. So up to C as the input. So that's why when read B as the input, no marking can be done and then move right. When read A as the input and no marking can be done and move right. So for example, observe here. So here, so when mark this A as star and then move right. So when we are moving right up to C, whatever the symbols we was readed, those symbols should not marked with any external symbol. So here we are reading B, so no change. That means it was as it is B and then move right. So here input is A, no change. That means A comma A and then move right. So whenever read C, no change and then move right. After that, when read A, then mark as star and then move left in this manner. So that's why here from initial state when read A as input, then mark as some external symbol star and then move right. And next we read any number of A's and B's, no change and then move right. Next we read when C as the input symbol, C as the input, then no change and move right. So after C, whatever the input we are expecting, so A is the input. So that's why when read A, it can be converted as star and then move left. So we will go back up to previously marked symbol. So that's why we will go back. So that's why move left. Next, so this is the transition. Next, when we are getting back, so immediately we observe what is the input symbol? C. So C is the input, no change, and move left. And next we can read any number of A's and any number of B's. Then there was no change, and then move left up to marked symbol. So that is star. So now we read whenever star as the input, then no change, and move to right for reading second input symbol. So that's why. So now star as the input and no change, and move to right. So now go to the initial state. From this, when we read either A, then convert as star and move to right. Same process. So in case here we read either B as the input, then that particular B can be converted as star and then move right until C. So that's why when we are moving from moving B converted as star and then move to right to check whatever the input symbol after C. So that is same or not. In this process we can read any number of A's and B's. So those A's and B's should not change as it is. Either whenever we read A, no change and move right. Whenever we read B, no change and move right. Whenever we read C, so no change and move right. After C, there is a chance to getting already marked symbols. Those are stars. So that's why those stars as it is and then move right. So now the input symbol we expected B as the input symbol. Why? Because recently we marked B as the star. So that's why after C we are expecting B as the input symbol. Then we marked as star and then move back. So when we are getting back, we can read any number of stars. Those stars can be converted no change and then move left. And then after completion of stars, we can getting C as the input. Then no change and move left. So whenever we are moving left up to end of the tape or up to recently marked symbol, in this process we can read any number of A's and any number of B's. Those A's and B's doesn't perform or doesn't change as any external symbols, and simply go to the left until we are getting star. So finally we are getting the star, then no change and move right, and then go to the initial state. So again, in case we are getting A as the input, just we assume ABA. So now third input symbol, so that is A. So then converted as star and move right. So whenever we are moving right, so here is there is a chance to getting any number of A's and any number of B's. So that's why here we are giving as loop, within loop. So we are read any number of A's, no change, move right. We read any number of B's, no change, move right. But whenever we read C as the input, no change, right. After that we are getting any number of stars. So that's why here we give loop. So when we read star, that means already marked symbols. So no change and move right. After that, so recently marked symbol is A. That's why we are expecting A. So it can be marked as star and move left. Whenever we are moving left, so we need any number of marked symbols, that is star. So that's why star is the input symbol, no change and move left. Number of stars will be completed. After number of stars, we are reading the C as the input, then no change and move left. So in this process we are getting any number of A's and then B's, then no change and move left. After that we are getting star, that means last recently marked symbol in first half of the string. Then we go to the initial state. After that, in case there was no input symbols, in case directly we are reading a C, so that means here last case. So that is the last case. Yeah. So here, so this is the last case. So after go back, move left, that is the star, immediately star, see, that means there was no input symbols to performing the marking. Then we will go for halt, that means accepted. So for that purpose we consider the transition. So we read either C as the input from initial state. So there was no input symbol, there was no A and then no B. So that means all are marked. So only next input symbol is C. Then no change and then move right. So in this process we are reading any number of stars, that means we are going to end of the input. So in this process we are getting any number of marked symbols, that's why no change and move right. Finally we reach the end of the input, that means there was no input symbols in second part of the string. So already after star, immediately seen is there was no input symbols to performing the marking in first part of the string. Now we check, is there any string, any input symbol is existing at end of the second input or not, second part of the string or not, for that purpose. So after number of stars, in case we read the end of the input, that means there was no inputs in between star and end of the input, that means all symbols are marked as some external. So that means no symbol can be remaining to performing the marking. So that means first part was completed, the all input symbols as marked as some external symbols. Second part is also all input symbols marked as some external symbols, that means both are matched. So that's why going to the halt, that means that particular string is accepted by the Turing machine. So this is the process of constructing the Turing machine for the given language L equals to WC W. So here very simple, when read first part of the string, first symbol marked as star, and check second part first symbol same or not, in case same then performing the marking and move back, read second input symbol and mark as star or some external symbol and move right to check after C, that means the second part of the string second symbol is the same or not, in case same performing the marking and then move left. In this process we finally are constructing the Turing machine for the given language L equals to WCW. So this is the process of implementing the Turing machine. Thank you.